called it? AFD? No. ADF. Close one, sir. Close one. Oh yeah, close one. Yeah, it would have been. That could have turned out quite badly. So this is quite it's a gimmicky application data flow diagram for that app I'm on a team producing this application, and this is just an application that serves books to users. Now you don't have to understand everything about this, but I'm just showing you the type of things you would expect in this design. Okay, so it's not just designing what the website looks like. It's not just designing pictures and logos and all of that kind of thing. It's actually designing how the website is supposed to work, right? Like how the end user accesses the website, where the website fetches specific things from, how it fetches those things. So the design process is slightly more technical than you would usually associate with the word design. Okay, and there's an important word to know here: architectures. Okay, we'll discuss this more in a bit though. Okay, so architectures, models, plans. That's what happens in the design process. The development process, well, this is where you actually implement the design that you made inside code or a database or other software solutions. So this is where you actually create the application. This is what we've been learning for this entire course, basically. So we don't have to spend much time on that. Testing, very important. Okay, it's test that software satisfies the requirements and, more importantly, like industry standards. Okay, so you want to obviously meet the business requirements, but that's almost implied. It's like, do you meet the business requirements as well as your competitors do, as well as your user expects you to, as well as your boss expects you to, things like that. And lastly is maintenance, which we'll discuss more later. Okay, so if you didn't do the required reading, you should be pretty much up to date, I suppose. Obviously, some of the later questions you might struggle more to answer. Okay, I'm glad I started recording, and I think I turned on. I'm sure I clicked the text box to record audio this time, so that's the important bit as well. Okay, so let's discuss each step in a little bit more detail with some graphics. So how the requirements process usually works is you'll be approached by a faceless person in a suit. Okay. And like a business person. Okay, and this person has a lot of names. You might call them your boss or the product owner or the business owner or even your partner, perhaps, right? Like if you're studying or something, someone might approach you from business faculty or something and get you to cooperate on a business project with them. So it's just a random person who's coming to you. Or more specifically, they're going to a lot of people. Okay, because they're panicking. They're just begging someone to develop an app for them. Okay, because they don't have the skills necessary to develop this application themselves. Okay, and they don't even know if it's possible, actually. So they'll contact a bunch of developers, and obviously they'll be turned down a lot. You guys will be surprised how difficult it is in industry to find a developer who actually can do what you want them to do. It's like it's a big problem, actually, which is why developer jobs pay very well nowadays. So this person will be going around asking a bunch of people for help. Okay, eventually someone will come to them, and this person could be in-house. They could be in the company that the business owner or product owner works for. They could be just a random person, but this person is like a nerd shepherd. Okay, they have a bunch of developers. They have friends who know how to develop apps, or maybe they're a team leader or something like that. They've got the resources to develop the app. Okay, this is what this person we might also call a scrum leader, but you'll hear more about that later. Okay, but this person is also maybe a business analyst. Okay, business analyst. So they are almost like project management. If you've heard the word project management, a business analyst does a similar thing in the context of programming. Okay, and this person will say back to the faceless person in a suit, yes, I have a flock of developers who can create the application that you're looking for. Maybe. You just need to be more specific, right? Tell me what's going on. Okay, so then the faceless person in a suit will respond by saying, you know, they'll say something airy-fairy. It won't be technical yet because they haven't learned how to be technical, right? So the example here is, yeah, our app idea is called I Levitate. It is a button that allows you to levitate. We already have the copyright. Can you get it done in 2 weeks? Okay, so they'll come to you with something that may or may not be possible, that may take 5 years or 1 year. And a business analyst is a person who will convert this crazy idea into something that their developers can understand, okay, to actually be able to finish the project. All right. So the process of requirements analysis is taking a gibberish from a product owner and getting that gibberish into specific technical requirements, okay, for an application. And you can see this, and what's cool, guys, I didn't actually appreciate this the first time I learned the concept, is that this is actually considered a job. Like your whole job can just be translating people's ideas into technical requirements without actually even developing them yourselves, which is pretty strange. But it does give you an idea of how difficult this process is. So I've created like a little standard example where there's some gibberish on the left, and we're going to have to translate it into technical requirements on the right. You know, more technical requirements, if you like. Okay, so what the product owner says and what the analyst needs to hear. Okay, and you guys are going to help me complete this table. I'm thinking that one way we could do this is to open Google Sheets and get you guys to all just type in cells. That could be a faster way of doing it. Although maybe we can save that for later because we have something. Yeah, okay, we'll test out that idea later, and because we have an easy way to test it out. Okay, so for example, if your product owner tells you, okay, we want people, again, they're not going to say the end user. They'll say something like, we want you to be able to upload videos to our site. Okay, so you're developing an app for this person, and they tell you this. We want you to be able to upload videos to our site. And that's about as specific as they will ever be. So at WITS, for example, in third year ComSci, you get a little project where one of the lecturers is your product owner. And they'll tell you just some super abstract thing, and you have to somehow turn it into like a final product that they're happy with. Okay, so that's the game we're playing here. So if a person tells you, we want you to be able to upload videos to our site, can someone suggest just 1 or 2 ideas, questions that you should be thinking as a technical person trying to achieve this goal here? What do you think you would be thinking when someone says, I want you to be able to upload videos to our site? What can you already start asking? What can you already start thinking about? Any suggestions? Feel free to turn on your mics. It's not, because interaction can be more difficult through chat. Although I guess it has been fine lately. Hey, what file formats? That's a very good one. The name of the site. That's also probably a good question to establish. But yeah. Let's focus on like just breaking down the one thing into technical requirements, because like branding might be more of a separate issue. This file formats thing, that's good thinking, right? I mean, the other thing is that videos are gigantic, guys. Like, it's actually very difficult to serve videos. Like, do you know how expensive hosting is? So maybe we can think along those lines as well. How long are these videos going to be? Exactly. But also even more technical than that. I mean, you could be even more fundamental. So some suggestions I had here. As soon as you hear this thing of, we want you to be able to upload videos to our site, you should immediately go, okay, we would need a very fast server. Okay, and that costs a lot of money. And there are so many different hosts you can choose from. Let me just mute my phone quickly. There are so many different hosts you can choose from. Google Firebase, Heroku, Microsoft has their own things, Azure, I think it's called. You also have to support multiple resolutions, right? Is it going to be SD, HD? Can you tune the quality yourself? Will it be like 360p, 480, 720 like YouTube? Yeah, video formats I mentioned as you did too. That's a good one to think about. and also just thinking about how expensive it's going to be to store all of these videos. So to give you a good idea of this, YouTube actually loses money every year. For Google owns YouTube, and YouTube is a net loss for Google. So they have billions of users, but because it's so, or not billions, millions of users, but it's so expensive to host YouTube, so expensive to host all of these videos, that they actually lose money on it every year. So like these kinds of questions would immediately come up, right? And then if the product owner next says, your friends must be able to view them. Okay, so they've now told us two things. Okay, we want you to be able to upload videos to our site, and they said your friends must be able to view them. So what questions are we asking now? What questions, what requirements do they exactly? Yeah, there's now this issue of public or private access. Can only friends see the videos? Can everyone see the videos? I mean, there's an even more fundamental question than that. If I say your friends must be able to view them, what questions now do we? How should they view it? Yeah, exactly. Even more fundamental than that, it would be, yeah, exactly. Even more fundamental than that would be what's a friend? What's a friend? How do I define a friend? Well, now I need a relational database. We now also will need to do dynamic web design, right? Oh, yeah, exactly. How do you share it with friends? Notifications? Yeah, very good points, guys. So you can see from one small sentence from a product owner, you get a ridiculous number of considerations. Okay, there's lots of questions to ask, right? We know, like, if you say friends must be able to view them, well, now you need a whole class defining what a friend is, right? You need a way to add friends, remove friends, block friends, share with friends, all of these ridiculous things. Okay, all of those have to be defined somewhere. Those relationships have to be stored somewhere. Okay, I mentioned here dynamic web design. So now, like if you have add buttons and all of these other things, and your what you see on the site has to be filtered by who you're friends with, that requires the website to be dynamic. If it was just a site where I upload videos and they just appear on my screen when I access the site, that doesn't require any changes, right? You could just add the videos, and it just goes down like almost how Google Images might work. So yeah, it like just saying friends adds a whole bunch of questions to what's happening here. And then on mobile devices and the website. So now they've said, we want you to be able to upload videos. Your friends must be able to view them on mobile devices and the website. So now what questions do we have to ask? What other requirements exist now? Yeah, exactly. So just saying this on mobile devices and the website, yeah, applications is a good point. Responsive web, exactly, because now it's this issue of, well, if you're accessing on a desktop, I have 1920 by 1080 pixels to work with. And if you access on a mobile device, I've suddenly got like a tiny little screen to work with. So now I have to render videos at all of these different resolutions. You have all the buttons and all of the design elements have to work on all of these different screens. Compatibility becomes a huge issue. Yeah, exactly. Like how on a computer you might use, for example, actually a nice one that we've seen ourselves is like when you hover over buttons. See when I hover my mouse over buttons, they light up like that. On a mobile device, there's no way to hover. So how do I signify if it's a different event, right? Remember we discussed this would be on hover, but like it's a different event when you tap something with your finger, when you swipe something. Those are all different events, so you'll have to program for all of those different ways to input. Okay, so that would be, yeah, exactly. If you're moving a mouse, that's different from tapping and using touchscreen. Yeah, so the ones I mentioned here, you now need a web backend. So what you would usually do to create something for mobile devices is you'll create a website first. It might not be accessible to the public, so it might be like it's like a hidden web server. Okay, and then your web applications will all contact that same server. so that whether you're accessing your account through the iOS app or the Android app, okay, whatever you're accessing your account on, it's the same account on the same database. Okay, so we would call that a web backend, and you need that for now iOS and Android applications. And just saying mobile devices and the website. So just to give you you guys an idea of what a project like that, what the scope would be, that would require development in at least 3 different languages. Okay, because for iOS apps, you need a language called Swift. For Android apps, you'll need to use Java, and you'll need some web frameworks for the web backend. So that's like Django, which is Python, Node, which is JavaScript, or ASP.NET, which is C#. Different search engines, precisely, different browsers, probably more specifically. You would need different browsers. You would have to serve the application in a bunch of different places, right? You have to go and sort out accounts and stuff with iOS, with Android, with Play Store, and yeah, it's like a crazy huge problem. So from these 3 sentences, right, what a product owner might see as extremely simple is actually a very difficult, very technical process. Okay, and so this is what this requirements analysis is. Okay, converting gibberish essentially into actual workable solutions. Okay, so at this point, after seeing all of this, you might say just these 3 sentences that the product owner has said, this will take you like a year of development, maybe even more, to get to even a partially workable solution. Okay, so it's quite scary stuff, actually. Okay, so the last thing we have to discuss on requirements analysis is that there's different types of requirements. Okay, so there's functional requirements and there's non-functional requirements. For those of you who did the extra reading, I assume the book explains this pretty well. A 1-sentence explanation really is all you need. Okay, so and the names are pretty self-explanatory, so maybe some of you can guess. I won't ask you to type it out because we know that people will just go to the book and copy the exact sentence. So so functional requirements are just specifics regarding what the system should be able to do. Okay, so looking at our example here with this little video app, can someone give me an example of what a functional requirement would be? What's a functional requirement of our little video app here? I'll give some time for people to type. So this is specifics about what the app should be able to do. Yeah, you need to be able to upload videos. You also need to be able to view them, maybe like them. You need to be able to add a friend, right? There's lots and lots of different options we could have on that, right? Lots of different functional requirements. Can you guys, so then a non-functional requirement, subscribe, yeah, precisely. A non-functional requirement would be, but you see, this is another interesting thing. Mentioning subscribe here, right? So you see, it's not necessarily mentioned in what the product owner says, but like when we think of a video hosting platform, subscribing to a particular person is like a natural thing to assume, right? So what you have to do, and in that little WITS assignments in 3rd year, it's what they encourage you to do, is the product owner will say things, but they're never specific enough for you to actually develop what they want, right? Like if you develop exactly this and take it back to the product owner, like exactly what we discussed here, after really like quite deep discussion, and take it back to the product owner, it's a high chance they'll go, but what about subscribing? Even though they never mention subscribing, because they'll just assume like, oh, obviously it's a video platform, let's add subscribing. So you need to ask the product owner like exactly what their vision is, right? And you have to really focus it down. And this is a difficult thing to do. Like this is a whole job. So yeah, cool. So that's a good point. But yeah, so functional requirements. And then non-functional requirements are quality requirements. Okay, how we were taught it. It doesn't mention it in the book, but basically any word ending in "ity" is probably a non-functional requirement. So with that hint, can you give some examples of what our video service platform would require? Would advertising be a non-functional requirement? No, I would qualify this as a functional requirement because it's super linked to your profitability. But obviously there's gray area. There's definitely gray area. Like supporting, say, Google's API for advertising, that would be non-functional. Yeah, exactly. There are gray areas, definitely. But here, usually just think words like itty. Okay, so scalability, maintainability, testability, security. Okay, all of these things are non-functional requirements. So our one would definitely require scalability, right? Because if people are uploading lots of videos, that's going to cause a lot of issues. Okay, if you don't have a scalable server, we are very quickly going to run out of space. Okay, so yeah, that's just the difference between functional and non-functional requirements. The clue's in the name, really. So don't worry too much about this. And also just remember this hint, the itty thing. If they ask you like, what's a non-functional requirement, you just look for the one with the most itties. Compatibility would definitely be included there, yeah. Cool. Okay, so that brings us to the end of requirements analysis. The next stop was design. All right, design. So I've split design, or the book as well, kind of, but they don't obviously discuss it in too much detail here, but they give you an example of what designers would be in this context. Okay, so in the book they mention architect and user experience designer. Okay, and yeah, that's good. So cool. We haven't discussed the concept of architecture though yet in the whole course, and the book hasn't really either. So we're going to discuss it a little bit now. I'm going to give you an example of two architectures. One we've worked with before, and the other one we're going to work with later at the end of this lecture. So here are our two examples of architecture. Okay, so in the book they say an architect designs the technical blueprint of the system. This includes identifying components and services, their behavior, and how they interact with each other and with the external world. Okay, so that's a little bit, abstract. So these are an example of a thing that, this is simplistic, obviously. It would be much more detailed than this in the real world. But these are two examples of architecture diagrams. Okay, so if you're a software architect, this is the kind of thing you would be expected to come up with. Okay, so on the left, this is what we would call an event-driven architecture. And that word events, you should recognize that word events. I'll discuss this more in detail though. And on the right here, we have what's called a model view controller architecture, an MVC architecture. This is probably one of the most popular architectures on the web at the moment. So this is what Instagram is made on. The site that I'm developing, EdgeAssess, is made with a model view controller architecture. But an event-driven architecture is what we would use for that video app we were discussing earlier. So let's discuss what an event-driven architecture is. If you guys remember back to when we learned about events, if you weren't there, don't worry, because you'll probably be able to get it. We had a publisher, we would call it, an event publisher. In this little diagram, it's called an event producer. Same thing. Okay, and that would just shout, like, I uploaded a video, was the example that we did, right? And essentially, all of these, what an event-driven architecture would do is say every component of your app, all of the components, must be implemented in events. Okay, so what the architect is trying to do is define a standard, okay, that'll be enforced across the company. So if you're a software architect, you'll decide on the architecture for the system. You'll give like examples of how you would add things to the system. Like, for example, if you're doing an event-driven architecture for a video website, you might give an example of how to upload the video using an event. Okay, and when all of the other developers make changes, they'll be expected to change things within that architecture. Okay, so when they add something, it must be added as an event. Okay, And how an event-driven architecture would work is exactly how we saw it in that other diagram. You would have a bunch of event publishers shouting, like going, hey, this event just occurred, this event just occurred. They'll throw it all on what we would call an event bus, which is just like a collection of all the events that have occurred. And the subscribers will subscribe to particular events. And so they'll wait for a particular event to happen. And when it does, when they see it on the event bus, they'll act. Okay, so and your whole app would be developed in that way. Okay, this is a bit confusing, but you can see it would make sense with something like videos, right? Because the reason we even would use the word subscriber, right, is because in an event-driven architecture, the way you think of a subscriber working on YouTube is the same way a subscriber works in this event-driven architecture. Okay, like when a video is uploaded, the subscriber is notified. Okay, so that's how the event-driven architecture works. When something occurs, the event is announced, and all of the subscribers will act in a particular way as a result of that event occurring. Okay, but yeah, this is just an architecture diagram. That's what you would call it. Translating this into code is slightly more difficult, as some of you have seen. What about the actual hard? That's a good point as well. It's, again, if you're a huge company, that's something you would consider. But nowadays, that would be more like, what about the service I am using, right? Like you would go, am I using Google Firebase or AWS? Because they'll provide the service for you. Very seldom nowadays will a company get to the size where they actually feel justified in buying their own servers. Okay, so on the right, we have what's called a model view controller architecture. Okay, and yeah, so I was just giving you another example of an architecture diagram. We'll see this one in more detail later, but you can see it's pretty nicely explained in the diagram, actually. So a model is the thing that handles the logic for contacting a database. So it handles how the data actually works. So the user at the end will never see this, okay, never sees this. Okay, the view handles how the user sees the data. Okay, so it handles it provides like a template, for example, for how the user will see the data. And the controller handles how we take the data from models. So the model handles how the data looks. The controller takes the data from the models and formats it in a way that the templates will understand, that the views will understand. Okay. Again, don't worry too much if it's not gelling with you yet. We'll see this architecture in practice a bit later. Okay, and so you'll get to see what it looks like in code, and maybe that'll make a little bit more sense. Okay. Anyway, so that's what an architect would do, a software architect. We also in the book saw this user experience designer, okay? And they will design how to navigate between the different parts of your application or your site or your system, whatever you're creating. And yeah, you see, the thing is, user interface design is often underestimated in terms of like how complicated it is. Like front-end developers get a lot of flack, but this is actually, it's a very difficult thing to do. So you could also call this product design, okay? Because this is what the user sees. How do you expect the user to interact with the site? And there's a lot of very finicky things that go on in this, particularly nowadays, due to this issue of responsive design. A nice example I can show you guys of this, actually, that might be quite interesting, because it'll shock you. Let me find this thing. Fav icon all browsers. This shocked me recently, which is why I'm going to show it to you guys. Okay. So let me just find out where. Okay. So this is a small example of this. Okay, so you see all this code here. Okay, this is just pointing to different images. All right, it's just pointing to different images. But all I want you guys to appreciate is this looks like a lot, right? It's 20 lines. Okay, it's 20 lines. This code is what is required. You see these little icons here next to like that little picture of a cat there, that little Heroku K there, the little T next to the Rex tester thing. These are called fave icons. Okay, and you can so it's like the logo of the site, like YouTube's little one there. All of this code is required for that fave icon to be displayed on all devices. Okay. So you see, that's a very tiny thing, right? You might think that's trivial. You might go, oh, I mean, of course, you just show the icon, right? But actually, every single device expects this to be formatted slightly differently. Some of them want it to be 48 by 48. Some want it to be 96 by 96. Some want it 512 by 512. And so actually, it's quite a crazy thing to get that logo to display on all different devices. Okay, so that's just one tiny, silly thing that would be a part of like the front-end design of a website that is actually probably more complicated than you would initially appreciate. Okay, so anyway, cool. So user experience design kind of like designing how the user will interact with the site, how they'll navigate between the different pages on the site, all of those kinds of things. But also there is more technical product design involved in this. Like, for example, if you're creating an e-reader, you need to be able to bookmark specific pages. That would probably actually be handled by like a front-end product developer. Okay. Yeah, we will. Cool. So the last thing I wanted to include in design is planning. Okay, they don't mention planning here, but this should go under design as well. This is where you would decide on things like what languages will you be using, what servers, like hardware would also, I mean, this is mainly software design, so we wouldn't consider that too much, but what services you're using is definitely important. So like you could see that as whose servers are you using, like Google's or Amazon's or Microsoft's. What frameworks you're using. So C#'s framework for web development is called ASP.NET, ASP.NET. But there's also Django, there's Node, there's a bunch of different frameworks that you can use to develop just websites, and there's a bunch of other ones to develop applications. So a lot would go here. Would you include budgets in your design? Yeah, I suppose for the business analyst, it definitely would be, but we're focusing in here on the design of software. Okay, so let's not think about all of these other things. The business analyst would probably handle that kind of thing in the same phase, though, definitely. But we're less concerned about that and more concerned about the software development side for this course, given that it is software development fundamentals. Yeah. Okay. Wait, should we break in 5 minutes instead? I guess it doesn't matter if we break now or... Okay, so yeah, lots of stuff goes into this. Like it's quite a complex procedure. I think let's do a break and then start on the next one. Although, wait, no, because the next one's development, hey. Okay, so I didn't actually say anything about development because this is what we've been focusing on for the whole course. This is where your developers work, okay? They also mention database administrators is a good one. Technical writers. This, I think a lot of companies underestimate the importance of, actually. But like what a technical writer will do, so if you go on GitHub and you find like any sort of repository, what a technical writer will do is write stuff like this, okay? This is the README for this site, but it's like documentation, details on how you can actually use the site and how you can actually start developing. Quite an important thing, because when you hire new people into your company, if your applications aren't well documented, then it's very difficult for them to actually start working with your code, right? So somewhere you need to note down how exactly do we do things. Okay, because different companies will operate in different ways. So this is what a technical writer would do. A technical writer would write up the documentation and stuff for the site. Database administrators, self-explanatory what they would do, although it's also very difficult. And developers, again, they develop. Okay, cool. So the next bit would be testing. And that's going to be a long bit. So I think let's take a break and then we'll start with testing. So let's come back at, shall we do 5-minute break? This is actually taking us longer to get through than I expected. Although we still have quite a lot of time. Let's just do a 7-minute break. We'll start at 4:20. Okay. 1620. Cool. It's nice. Okay, let's get started again. Are you guys back? Post in the chat if you are. Good stuff. Right, at least 2 people. That's enough to keep going. Okay, cool. Awesome. So we've got through the first 3 stages: requirements, design, development. The next one would be testing. Okay, so and again, because it's a cycle, obviously you'd be jumping around a lot in practice. But this would be a sensible way to get started as well, right? So, all right, testing. So broadly speaking, there are 2 approaches to testing. Honestly, I think the distinction is maybe a bit strange to make here because there's also levels of testing. But yeah, so keep those separate in your mind. There's approaches to testing and there's levels to testing. Okay, so the 2 approaches to testing, what they call them in this book at least, is black box testing and white box testing. Okay, so can someone tell me what black box testing is? Because these 2 you would have seen in the required reading. The levels of testing you wouldn't have seen yet, probably. Black box testing. What is black box testing, guys? I think once you know the definition as well, it is also you can glean a lot of information from the name. Not really. Yeah, in a way. I think a nice way of characterizing it is you picture yourself as a totally clueless user and you just use the application. Okay? And then you just document any errors or problems that you would encounter. Okay, so this is like testing without knowledge of the system. Okay, you must use it as if you're actually a user. Okay, so you mustn't use developer knowledge necessarily. Okay, and white box testing is just the opposite of that. Okay, because as a developer, right, you're the developer of the system if you're testing it, or you're a software tester, like you're some way associated with the creation of the application. As a developer, you know things about how the system is created, about what errors you were worried about when you created it. And you can use your knowledge of the system to program your tests to make them difficult and really meaningful. Okay, so like it's frequently used in lots of industries, right? Like on aeroplanes, they call it a black box, but typically you just what it denotes, what black box denotes, is that it's like hidden from you. Okay, so it's like blocked off from you, so you can't see inside. You can only see the outside or recording or things like that. Okay, white box means that it's just totally open. You can see what's inside it, right? Pretty silly to make this distinction on the context of testing, I would say. I think the next characterization of the different levels of testing is much more beneficial, but do just know what black box and white box testing are broadly. Okay, so in white box testing, you're using your knowledge of the system. In black box testing, you're just testing different inputs exactly how a user would and getting a specific output and just making sure that that input corresponds to the correct output. Okay. The next definition of testing, I think, is much more interesting. So the next definition is actually just, so where you stopped reading was like the bottom of page 68, and the levels of testing are like on the bottom of page 69. That's where they start. So would black box testing be functional? Both of them are testing functionality. Both of them would be testing functionality. It's just that one of them is abusing knowledge about the source code of the system. Okay, if you have access to that source code, you know how it's programmed, you know how to break it. You don't use it as just a normal user would. You use it as if you're using it with the extra knowledge of exactly what edge cases would break the system. How is it made? Okay. Do you get this? It's maybe do you guys want to spend more time on like this distinction? Are we comfortable with it? Okay. Okay, the next one splits testing into 5 different levels. And this one is much nicer, much more, it's like beta. Yeah, actually, think about it that way, except it's usually done by developers as well. But yeah, I think you would qualify beta testing as a form of black box testing, but you would also qualify it as a form of acceptance testing. And that's much more interesting. So let's just get into the levels, and hopefully it'll put everything together for you. Okay, so this bit splits testing into 5 different levels. And it's not like they have to be black box or white box. This is just different ways of qualifying. These are totally separate ways of qualifying the different types of testing. Okay, so black box is like user testing, and white box is like developer testing, if you like. And in the levels of testing, it's like a separate qualification. Okay, this is splitting testing into 5 different levels. It's much more interesting and more intuitive, at least to me. Okay, so we'll start at the lowest level of testing, which is called unit testing. So you guys know what units are, right? Like you'll have a unit of measurement, and it's usually denoting like the smallest possible thing, or like a specific quantity, but like the smallest amount of it. You might say like 1 meter. Right, is like a one unit meter, if you like. Okay, so this is testing the smallest possible pieces of code. So it's testing methods, for example, like specific units of code. Okay, like a specific block of code would be qualified as a unit. Again, there's lots of gray area. It's very fuzzy, but I'll give you an example of an actual unit test now in Rex Tester. So we can see what we mean when we say a unit test. No. So an individual unit test will be the fastest. Developing unit tests definitely takes very long because you have to test every single bit of code that you've created. But like you'll see when we get to the later stages of testing, they're much more complicated to actually test those kinds of things. But you'll see what a unit test is now, and you'll see that it's basically the simplest, like a very simple way of testing. Okay, so what we'll do is we're going to pretend that we're programming a bank app. Okay, an application for a bank account, for example. So I'm just going to say class bank account. Okay, so I'm just creating a bank account. Can you guys give me some obvious properties that a bank account would need to have? Money. Yeah, a good start. Exactly. Savings, yeah, and so let's stick with money and a name for the person, right? And the bank account needs to be linked to someone. Okay, so we're gonna say, and the other big thing, okay, when we're talking about encapsulation, if I ask you what encapsulation, yeah, account number is probably a good one as well. If I ask you about what encapsulation will our properties in our bank account be using, what will you guys tell me? Do you remember what the word encapsulation means? What would they be? You don't remember. Okay, let's see if anyone does. What words will I be using to create these properties? What encapsulation level? What private? Good stuff. Yeah, so encapsulation was a word in object-oriented programming, and it was used to refer to public, private, or protected. Okay, and in a bank account, everything's going to be private, right? We don't want you to just be able to publicly access and change all of the person's balance. Okay, so we're going to say private string customer name. Okay, that's where we're used to seeing something like that, right? And we'll say private double balance. Okay, private double balance. Okay, let me think. I think my slides are maybe a bit too long for 1 hour and 30 minutes. Not sure if we'll be able to get through everything. Okay, so private string customer name, private double balance. Okay, now guys, when I create a new bank account, I obviously want to set the customer name and the balance. What little structure am I going to use to set the customer name and the balance, to initialize them? What structure would I use to do that? Nice. Okay, exactly. We're going to use a constructor to initialize the values. Okay, so something like that. And it'll take in two things in this case, a name and a balance. Okay. Obviously, usually we would be able to get all of this, get through maybe this entire section without actually programming anything. But I think it's better to not get so rusty. So I think let's spend a little time programming all the time. Okay. Customer name equals name, balance equals balance. Okay, so let me just make this principal. Okay, we'll call this their principal investment. Okay, principal. Okay, so that will allow us to create a new bank account. Pretty simple. We've seen classes a lot before. Okay, so I'm creating this class to demonstrate what a unit test would be, what one example of a unit test might be. So we're going to have one simple piece of functionality that we're going to create for our bank account, and we're just going to test if this actually works, if this very specific piece of functionality works. And just testing that in a total microcosm, not caring about what the rest of the bank does. We're just testing this in a microcosm and we'll just test if that works specifically. And the method we're going to create is a method that allows you to withdraw money. Okay, so all we need to do is the person will specify an amount that they want to withdraw. Okay, they'll specify an amount that they want to withdraw. And we'll just, if it's a valid amount, we'll deduct it from their balance. Okay, so it's a very simple method. Before we do this, we're also going to have to be able to see the name and the balance. Okay, so let me guys remind me, if a property is private, if a field is private, how would I access it from outside the class? What structures would I need to say access it and change it outside the class? Get set. Yeah. Oh, wow, all of you guys got it. Good stuff. Yeah. So we would need getters and setters. Precisely. So in this case, do I want you to be able to set your balance from outside the class? Do I want you to be able to set your balance? No, I don't. So will I add a getter and setter, or what? Like, which one should I add? Which ones should I add in this case? Just get. Okay, cool. Yeah, you guys seem to be down on that. So I also don't want you to be able to set your name from anywhere, right? I only want to be able to set your name. You must just be able to see it. Okay, so we are only going to add a getter. So I'm going to say public string. We'll call it name, and I'm just going to add a get. Okay, and that get is just going to return our field customer name. Okay. If I added a set, that would also allow me to change it, which we don't want. Okay, and I'm just going to pretty much copy paste this whole getter and setter structure and just add the exact same thing for the balance. Okay, I'll call this balance, and that's just going to return the actual balance. Okay, so now we're able to see the balance and see the name, but we're not able to change it from outside the class, which is ideal. All right. Okay, now we can write this withdraw function. Okay, so I'm going to make it intentionally wrong so that we can see the unit test fail. Okay, but I'll also make it wrong in a slightly subtle way. Okay, so what is the main thing? If I'm programming a thing that allows you to withdraw from your account, you specify an amount, a double, you give the method a double, and it will deduct that from your balance and like give you that money. What is the main thing that I as the bank want to do here? What is the main thing that I want to check for? Anyone know? Think about it if you were a bank and someone was withdrawing. Yeah, okay. That's a good point. If it was a more complicated thing, yeah, you would want to verify the accounts in some way, probably. But yeah, the main thing is that they're not requesting more money than they have, right? Like if they're allowed to withdraw the funds, that's cool. But the simple thing that we want to make sure is that the amount that they want to withdraw is less than the amounts in the accounts, or then I'm just giving them free money, right? So, which would be nice of me, but probably wouldn't make for a very successful bank. Okay. Cool. So I'm making this function debit, and it's just going to take in a single double called amount. Okay. And literally all I'm going to check, super simple example, I'm going to see if my balance, which I could access with just balance, but to be more explicit, I'm going to use this word, this dot balance. So that's saying my bank balance, this class is bank balance, is greater than the amount or greater than or equal to the amount, because they can withdraw all their money, let's say. Then I'm going to say amount minus equals. Do you guys remember what minus equals would do? Minus equals, or sorry, what am I doing? This dot balance minus equals, sorry. This dot balance minus equals amount. Okay, so this is just saying take the current balance and deduct the amount. Okay, and the other way of writing this that might make more sense, let's just write it out in full. We would say this dot balance minus amount. Okay, so this is just saying take the current balance and instead set it to the current balance minus the amount. Okay, pretty straightforward. And otherwise, yeah, let's just leave it like that. Now, currently, there is an issue here. This will not work, and it wouldn't be a valid way to debit a bank account in the way that we want to do. I don't know if any of you can see why this might be a problem, but we don't have to. That's the other thing. We don't have to be able to imagine how it will be a problem. Instead, we'll write a unit test. Okay, so what we would call this debits method is a unit. That's a unit of code. It's just one little code block, and obviously some code blocks will be much larger. But the point is, like, it's a piece of code that's performing a specific function. All right. And I just want to test that it does that thing correctly. Okay, so in our main method, obviously you would split your unit tests into a lot of other methods if you were doing it sort of professionally. But we're just going to create a very simple unit test. All right, so what I'm going to do is we'll create an example bank account. Okay, we'll draw a specific amount from it. And we'll tell the computer, like we'll calculate ourselves, we'll say if our system is working, if it withdrew the correct amount, then this is what we would expect to still be in the bank account afterwards. Okay? And if it's broken, then we must fix it. Okay, so how we would do this is we'll create a few variables. So I'll say double initial. So this will be the initial amount of money in our pretend bank account. So it will be like, let's say 100. Okay, 100%, 100, like 100 Rand, whatever. We don't have units here. Then we want the amount that we're going to withdraw. So I'll say double amount equals, let's withdraw 10. Okay. And then we need to tell the computer, what do we expect the result to be? Okay. Double expected equals. So guys, if I have an initial value of 100 and I withdraw 10, what do I have? Just to keep you awake, precisely 90. Exactly. So this is a very simple unit test, right? This is like what a standard user might do. Okay, I'm not using my knowledge of the source code to test this, right? I'm just giving a nice example. I'm just a user. This you might call white box, right? We're just throwing out an example, a seemingly realistic example. Okay, so how will we test this? Well, we'll create a new bank account. We'll say bank account, account equals new bank account. Okay, we'll set the name to, I don't know, random, and we'll put initial there. Okay, so what is initial? Initial is 100.0. Okay, so that's the initial value we're opening the account with. All right. So we're just creating a unit test here. So we've created an example account. Okay. What we then do is we want to withdraw amount from the account. So we have this amount variable. We're going to withdraw that from the account. So I'll say accounts, that's the account object, dot debits. Okay. And so that's the name of our method. And debit requires us to give it an amount to debit the account by, to withdraw. Okay, so we'll say amount. All right, let's just, because we've written a lot of code now and we haven't run it, I just want to double check that, I haven't left out any semicolons or silly stuff like that. Okay, I haven't, so apparently that's cool. So now we just want to test that the balance in our example account is correct. So what we'll do is say, I'm going to create another variable saying actual, okay, equals, and how am I going to get the balance out of the account, guys? Does anyone know? How do I get the account's current balance? We created that getter, right? Created that getter. So how am I going to access the account balance? Let me show you the class. Right? I want to access this balance variable in our ACK object. Okay, the name of the object is ACC. How am I going to access that balance? Account.balance. That's close. So you see balance with the lowercase b here is private, right? Balance with the lowercase b is private. Okay, yeah, closer. Yeah, this is good. Okay, so what we would say is the name of our object is ACC. So I'll say ACC dot, and the name of our getter is balance. Okay, capital B. Okay, so what that'll do is create a new variable called actual that has the account balance after the debit has occurred. Okay, and now how am I going to test this? I want to test, is account balance the same as expected? Okay, is actual the same as expected? How? What structure do we know, guys, that is good for comparing these two things? Hey, you even gave the operator. That's good. And what structure would I put that operator in? What structure would I put that operator in? Like, what's the little statements, if you like? Precisely. Awesome stuff. So we'll say if actual equals expected equals expected. That means our debit function is working, right? And otherwise, it's not working. So I must just print out a method. So I'll say console.writeLine, and a standard method we would say, so there's every company will have a different way for naming their unit tests, okay, because obviously in a big company you'll be running lots of these, okay, hundreds. So there'll be lots of unit tests, and so you want a very specific way to find out which one is broken. So we'll just say debit unit test passed. Okay, you would want to be maybe even more specific because this would be like, you want to even give the example values that you give. So this is debit with initial 100, positive amount, something like that, or whatever. So that's if the unit test passed, and otherwise the unit test failed. So debit unit test failed. Okay, so when I run this, it says debit unit test passed. Okay, so this successfully deducted 10 from the account, which was initially 100, and the actual value ended up being what we expected. Okay, now that was sort of maybe black box testing, if you like, to go back to that example, but this was also what we would call a unit test. This is a single unit test. I know, though, as the developer, as the person who programmed this, I know that it doesn't check if the number is negative. Okay, this is not checking if amount is negative. Okay, so I as the developer know that because we just created this. So if I want to intentionally try to break this, what might I do, guys? What if I say amount is minus 10? Yeah, exactly. So what if the amount that I want to withdraw from the account is minus 10.0? My expected value at the end should be 100, right? And if I run this, debit unit test failed. Because what would this do? This would actually make if the person tried to withdraw a negative amount from their account, then this would actually add, right? Because it would say, because obviously amount, let me show you in the debit function. Okay, so this comes in tests if this dot balance is greater than or equal to amount. If amount is negative, it will be, right? How do you withdraw? Well, exactly. But if you're a hack, it's like if you're at an ATM, this might not be possible. But through an online site, how are you going to control? You do have to test it. You see, because if we were actually creating this for an actual bank, you need to tell the computer that you can't deduct negative amounts. To us as a human, it doesn't make sense. But our debit function can support negative amounts because it's a double, right? Doubles can hold negative numbers. So let's see what our code would have done in this case, right? So it worked for positive numbers, but if we gave it a negative amount to withdraw, okay, hypothetically, let's say we were trying to hack the system, we were trying to break the system. So this dot balance will always be greater than or equal to amount if amount is negative. And then it said this dot balance equals this dot balance minus amount. So it would have said 100 minus 10. So what do you think that person's actual balance was after we ran this little example? What was the person's actual balance? Because what we ran was 100, exactly. We gave this person 10 Rand because they tried to deduct minus 10 Rand from their account. Okay, so this is the kind of thing that if you're a bank, you would want your system to not do this, right? It must, instead of doing this, it must say you're not allowed to use negative numbers. Well, exactly. So how we would fix this, it would be very simple. But remember, guys, this is why you unit test, right? Because it's easy to leave out an extra if statements. How you might do this is say if amount, just a simple way, is less than 0, console.writeLine, and then you would just print out like invalid amounts. Okay. And then just go return. Something like that. And now when we run it, it says invalid amounts, and then it says debit unit test passed. Okay, so we've now handled the case if amount was less than 0. Okay, so this is why as the developer of the code, you can find problems that will intentionally break it. Okay, so it's much more beneficial to do this kind of testing. Okay, anyway, that was just an example of a unit test. You didn't technically have to see that, but the point was that it's a small unit of code, one method, one algorithm, and we test that specifically. Okay. So there are 5 other types of testing. We'll discuss them theoretically. Then I'll show you an example of like how testing might occur in the real world, and then we're obviously going to have to stop today, even though we didn't technically finish everything I wanted to. And unfortunately, we won't be able to start insulting the other schools over our own personal website, but we'll get to that. Okay, so we know what unit testing is. It's testing the individual pieces of code, the individual methods, the small bits, okay, algorithms, things like that. Okay, but at a higher level, right, because like we can picture it in this bank thing. So we've seen one pretty subtle problem that occurred here, right? If amount was negative, our debit function, which we programmed, right? So, Alex, if you're still not quite getting the answer to that question, it's like we programmed the debit function, right? So if our debit function can withdraw negative amounts, then it can. We programmed it incorrectly, okay? Because it's like at a real bank, you wouldn't be able to do this precisely because a programmer handled that particular error, okay? But you as the programmer have to know that that's a problem. You have to see that that's the problem. Okay, so anyway, so we've seen one pretty subtle problem, right? So if we have this debit function and it's working as a debit function, okay? But there's a lot of other stuff that happens at a bank, right? Like what about if this is not a normal bank account? Like what if it's a credit account? Then actually I can withdraw money if my balance is greater than or equal to, if my amount is greater than my balance, I can still withdraw. I just go into debt, right? What about interest? Exactly. So there's a lot of other things, like the interest must be added to the correct balance variable at the correct time. Yeah, that's a very good example. The point is, our debit function is not working in isolation, right? It's working in a wider bank, okay? So we can perform unit tests that test that individual debit function. But when we integrate that function into the rest of with other things from the bank, like a nice example of this is that, damn it. A nice example of this is if we were running an actual bank, our balance would be queried from a database, for example. Okay, so the debit function might work here, but when I integrate with a database, what if the database query isn't working? That would then break my debit function, right? Because my debit function doesn't handle a case that states if the database is broken and I can't read the actual balance, then don't allow the withdrawal to occur, right? So there's a lot of other things that we would need to test for the debit function when we integrate it with other things. And that's called integration testing. So the basic thing you have to understand here is that units of code can work independently, and then when you put them together, they'll break, right? So you might have like a database query functionality for the balance. So you'll be able to query the balance from the database, and that might work on its own, okay? You might have another system that allows you to debit the balance, okay? And then as soon as you put them together, they break, okay? So you need to do integration testing. So after you put things together, after you put these units together, you test them again, okay? Then there's system testing, because all of your individual points might work together, but then in the whole wider bank system where we have things like interest and debt and the actual ATM machine having buttons on it, right? Like there's all of these other things to consider across the whole system. And once you've taken your units, you've tested them, you've integrated them together in some way, then you integrate those groups of units into the whole system, it might break again, okay? So you need to test everything together, like the final product, if you like, okay? And that would be called system testing, okay? There's then something called acceptance testing, and someone brought up beta tests. I think it was you, Alex. Acceptance testing would be a beta test, okay? So this is giving it to customers. Yeah, this is giving the system to customers and saying, do you like this? Is it fun? Is it working how you expect it to work? Are the buttons where you want them to be? Is there anything else you would like to add? So the acceptance testing it's not just customers though. It's also the product owner. So you have to go back to remember the faceless person in a suit? You have to go back to them and you have to make sure that they're happy with the product that you've created. Okay, so that's acceptance testing. And lastly, there's what we call regression testing. So for example, if this happens a lot in video games. Video games are a great example of this, where they'll upgrade the game, right? Like it'll be version 1 of the game for a while, and they'll add some bug fixes, right? There'll be bugs in the game, like, I don't know, something will be spinning out weirdly, and they'll add an upgrade to the game that fixes that bug. But when they add the thing that fixes that bug, the change that they make might break something else. Okay, so like your fixes, your upgrades might break previous things. Okay, and that's what regression testing is. So before you make upgrades, you have to test everything again, right? So just because your unit test worked in version 1 doesn't mean that your unit test will still pass in version 2. Okay, you have to test it again. So basically the regression testing is just saying that all of these 4 previous tests are a continual process. You have to repeat your unit tests, repeat your integration tests, repeat your system tests, repeat your acceptance tests every time you upgrade. Okay. It's like testing is a continual process. As you maintain the site, as you make changes and upgrades, you have to rerun the old tests that to make sure that your new things didn't break anything. Okay, and those are the 5 types of testing. So I much prefer this way of qualifying testing to that black box versus white box. Are you able to change the code in the game? I'm not sure. You'd have to be more specific, but yeah, it depends on the game. But usually that would be called cracking, right? That's breaking. That's illegal. But also mods, right? Mods are fine. Anyway, so yeah, there's all these different types of testing. Okay, that's the main thing. So there's these 5 different levels, and you should know what they are. Okay, unit, integration, system, acceptance, regression. Not super complicated to understand, but I do think it's quite interesting, right? So, unfortunately, we are running out of time. I actually thought we were going to go too short today. How would a game enable mods? Yeah, you see, when you're creating something like that, it's a mission, right? It's why a lot of games wouldn't add it, because it's difficult to do quality control. But how you might do it is before the mod is posted on whatever forum where you can download it, an actual system tester would make sure that your mod is of a certain quality. Okay. Anyway, yeah, so there's all these different types of testing, very expensive, very difficult to actually do them, but yeah, quite cool. What I want to show you is how this might be done in like a real world. Very simple example, but should be quite interesting. So I'll say, wait, we've only got 3 minutes left. Maybe I'll save this for next time. Yeah, it can be incentive to come back next week. Okay, because we'll start working with our own website next week. I did hope that we would get to it this week. I really did think I didn't have enough prepared for today, but apparently I had way too many slides. Anyway. Okay, cool. So in the last 3 minutes, you guys choose. Do you want to do a section 2 knowledge assessment as extra work, or do you want to read through the understanding testing section? Okay. Good stuff. I thought that would be pretty uncontroversial, actually. Bit of a false choice, though, since we will be doing both eventually. But yeah, cool. We can do the reading this week. But we will have to get to that knowledge assessment eventually. But I also want to put it off, because it's like... Anyway. Okay, so yeah, the extra reading will be... Yeah, just bottom of page 68 to top of page 70. Okay, and you can call it there. Bottom of page 68 to page 70, and I'll also post it on the WhatsApp group as per usual. But yeah, let me stop sharing my screen. Also stop recording.